Hi guys, I'm Mr. Joseph, a chemistry teacher. I'm back with my lectures. And today's lecture is a continuation of our previous lecture on lattice water, lattice energy. And we're meant to understand that lattice energy is the enthalpy change when one mole of an ionic solid is formed from its gaseous ions under what? Under standard condition. And there's a relationship between the lattice energy and the enthalpy change of solution. So today we'll be looking at the enthalpy change of solution, how we can deduce and use the term enthalpy change of solution. We'll be looking at how we can write equations describing the enthalpy change of solution of ionic compounds. And also we're going to use the value of the enthalpy change of solution to determine what the solubility of what an ionic compound. So with the help of the enthalpy change of solution, we can tell if an ionic compound is soluble or what insoluble. So we'll be using the value of the enthalpy change of solution to determine the solubility of what? Of an ionic compound. So please, I want us to listen attentively and get the best out of what today's lecture, because it's a continuation of our previous lecture. So there's a connection between what we've done in the past and what we're doing presently. Now, considering enthalpy changes in solution, when we talk about an ionic compound is formed as a result of electrostatic force of attraction between what oppositely charged ions, positive and negatively charged ions. Now, when an ionic solid dissolves in water, what happens is that the crystal lattice breaks up and the ions separate. Now, this process requires a large amount of energy to overcome the attractive forces between the ions, because ionic compounds are held together by strong electrostatic force of attraction. So water molecules are able to break up the giant ionic lattice structure and overcome the strong electrostatic attraction between oppositely charged ions. So how does this happen even when the water is not heated? So that's what we'll be looking at today. The process involves in enthalpy changes in solution. So looking at enthalpy change of solution, when we talk about a solution is a homogeneous mixture of a solute and a solvent, which is a uniform mixture of a solute and a solvent. During this process, energy is either released from the system to the surrounding, or energy is absorbed from the surrounding to the system. So when we talk about enthalpy change of solution, it is the energy released or absorbed when one mole of an ionic solid, which is the solute, dissolve in sufficient water, which is the solvent, to form a very dilute solution, which is an infinitely dilute solution. So solute plus solvent, you get you get solution. So the solute here is the ionic compound. The solvent here is water. So the water is in excess. That's what mentioned the fact of a very dilute solution. So it can be positive, which is endothermic, or negative, which is exothermic. So we define enthalpy change of solution as the enthalpy change when one mole of an ionic solid dissolve in water to form an infinitely dilute solution, very dilute solution, measured under standard conditions. That means the solvent is in excess. That's why it forms a very dilute solution. So it is the enthalpy change when one mole of an ionic solid. It has to do with one mole of an ionic solid. For example, sodium chloride, which is an ionic solid, dissolving excess water to form an infinitely dilute solution. So as you can see, these are equations describing the enthalpy change of a solution when one mole of an ionic solid, magnesium chloride, dissolve in excess water. So we put aqueous to form an infinitely dilute solution. So we'll talk about infinitely dilute solution. That means the solvent is in excess. It's just like dissolving a cube of sugar in a drum of water. You form an infinitely dilute solution. You're going to form a very dilute solution because the solvent is in excess. So the enthalpy change of solution of magnesium chloride is an exothermic process. That means energy is released from the solution of magnesium chloride to the environment, to the surrounding. They won't talk about the surrounding, the container, the beaker, even if you are part of the surrounding, the steering rod and the rest. Energy is released from the system to the surrounding. So the equation can be written like this. in this form. Either you use this form or you use what this form, and it's an exothermic process. Now this is the equation describing the enthalpy change of solution of sodium what? Sodium chloride. So it's an endothermic process. This one's an endothermic process. You can see that the enthalpy change of solution is what? Positive. That means energy is what? Absorbed what? From the surrounding what? Into the what? Into the system. So it can be in this form or be in this what? Or be in this form. So at least you should be able to what? Use an equation to describe the enthalpy change of solution of a certain or a particular what? Ionic compound. So it's as simple as what? A, B, C. So enthalpy change of solution is the enthalpy change when 1 mole of an ionic compound is dissolved in what? Excess water to form what? An infinitely dilute solution, or a very dilute what? Solution under what? Under standard conditions. So why do we need to know the enthalpy change of solution of an ionic compound? That's why we'll be looking at solubility of an ionic what? Compound. Now what happens is that with the help of what? The enthalpy change of solution of an ionic compound, it will help us to know which of the ionic compounds are soluble and what? Insoluble. In our secondary school, we say some compounds are soluble in water, while other compounds are what? Insoluble in water. So the enthalpy change of solution of an ionic compound is very, very what? Important. It will aid us, it will help us to determine what? The solubility of an ionic compound. It will help us to tell if an ionic compound is soluble in water or if it is what? Insoluble in water. When we talk about solubility, soluble and insoluble are only relative terms. Yes, even those compounds we consider to be insoluble, they are soluble. But the only reason is because they are soluble to a very small degree. Magnesium carbonate, for example, is regarded as being insoluble because only 0.6 gram of the salt dissolve in what? Every dn cube of water, which is almost insignificant. So no metallic salts are absolutely insoluble in water. Even lead carbonate, which is regarded as insoluble, dissolve to a very small extent. It's just like about 0.00017 gram dissolves in every dn cube of water, which is very, very small. So if salts were completely insoluble, they could not have a value for what? The enthalpy change of solution, because all salts, whether the ones who consider soluble or insoluble, they have what? A value for the enthalpy change of solution. So what happened with the help of what? The enthalpy change of solution, we can tell if a compound is soluble or what? Insoluble. Now, a compound is likely to be soluble in water only if the enthalpy change of solution is negative or has a small positive value. A compound is likely to be soluble in water. An ionic compound is said to be soluble in water if the enthalpy change of solution is negative or has what? A small positive value. So substances with large positive values of enthalpy change of solution are relatively what? Are relatively insoluble. Remember, I told you that soluble and insoluble are only relative what? Relative terms. That is why we're still going to look at the solubility product of what? Ionic compound, which is the solubility of sparingly what? Soluble salt. So with the help of what? Enthalpy solution, we can tell if an ionic compound is soluble or what? Insoluble. It is soluble in water only if the enthalpy solution is negative or has a small positive value. But those ionic compounds with large positive values for enthalpy solution are considered to be what? Insoluble. Now, having established the fact that enthalpy change of solution helps us to know which of the ionic compounds is soluble or what? Insoluble in what? In water. So with the help of the enthalpy change of solution, we can tell if an ionic compound is soluble or what? Insoluble. Now look at the question before us. These are examples. The enthalpy change of solution of some metal halides are given below. What do these values tell you about the relative solubility of these four compounds? So we are given what? The enthalpy change of what? Solution. For sodium chloride, the enthalpy change of solution is plus 3.9 kilojoule per mole. For silver chloride, plus 65.7 kilojoule per mole. For sodium bromide, minus 0.6 kilojoule per mole. And for silver bromide, plus 84.5 kilojoule per mole. So we already know that what? If the enthalpy change of solution is negative or have a small positive value, that ionic compound is soluble in what? In water. But if the enthalpy change of solution value, if it has a large positive value, we say that ionic compound is what? Is insoluble. So silver chloride, for example, the temperature of your solution is plus 3.9 kilojoule per mole. So it has a small positive value. So it's said to be what? It is soluble. Then for silver chloride, it has what? A large what? Positive value. The temperature of your solution is large. It has a large positive value. So it is said to be what? Insoluble. Now, then for sodium bromide, the temperature of your solution is what? Minus 0.6 kilojoule per mole. So it is negative. We say that one is what? Soluble in water. Then for silver bromide, it has what? A large positive value. So it is what? It's what? Insoluble. So with the help of the enthalpy change of solution, we can tell if an ionic compound is soluble or what? Insoluble. And we know that enthalpy of solution is the enthalpy change when one mole of an ionic compound is dissolving what? Excess water to form an infinitely dilute solution. That is a very dilute solution under what? Under standard condition. So with the help of the enthalpy change of solution, we can differentiate what? Compounds, ionic compounds that are soluble in water and ionic compounds that are what? Insoluble in water. So this is the task before us. You have to write equations to represent the enthalpy change of the solution of potassium sulfate, calcium nitrate, zinc chloride, and sodium bromide. So it's as simple as ABC. I'm going to solve the I part, then I'll allow you to do the II, and IV. So we'll meet in our next lecture. Please attempt as many questions as possible. And we'll meet in our next lecture. So it's as simple as ABC. So we have to write equation to represent the enthalpy change of solution of what? Potassium sulfate. So let me solve that. We'll talk about enthalpy change of potassium sulfate. The enthalpy change when 1 mole of potassium sulfate as an ionic solid is dissolved in water to form what? A very dilute solution, an infinitely dilute solution under standard condition. So this is the formula for potassium sulfate, which is K2SO4. It's an ionic solid, consists of a positively charged metallic ion and sulfate ion, negatively charged anion. So if you have to write your equation to represent the enthalpy change of the solution, it will be potassium sulfate, which is solid, dissolving excess water, aqueous solution dissolving excess water to form a very dilute solution of potassium sulfate, which is K2SO4 aqueous. So it's as simple as what? A, B, C. So please, I want us to attempt II, and IV. So it's as simple as what? A, B, C. So thank you very much for listening. Please feel free to reach out to me if you encounter any difficulty. Make sure you go to the comment section and give your feedback. And we'll meet in our next class. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Feel free to reach out to me. Thank you very much. Mr. Joe, your chemistry teacher. Thank you for listening.